Hi, I'm Mitchell Greenberg. I'm a graduate student at Texas A&M University, completing my MBA and Master's in Biomedical Engineering, and I'm with Scepter Medical Devices. Unfortunately, at least one of us here knows someone who's had to go through chemotherapy for cancer treatment. And chemotherapy is just one way that we can apply our device. I'm here to talk about central line infections. Central line catheters are used in the ICU as well as with patients with dialysis and, as I mentioned, chemotherapy. When you're in that position, the last thing you want to worry about is an infection while you're in the hospital. And these infections with central line catheters are the most costly to treat out of all hospital-acquired infections, at about $46,000. And on average, each year, currently, there's 30,000 infections. This is pretty large because there's $1.7 billion on average being spent by the hospitals treating these patients, and these are preventable infections. In addition, there's $1.7 billion being spent by Medicare and insurance companies on dialysis patients. This picture here is of a healthy central line catheter. You'll notice the rash and the redness, and that's due to the repetitive tapings and cleaning to prevent the infection. However, it's just not working. The central line goes straight to your heart, so an infection can be fatal. 1 in 4 die from these infections. And there's just a zero tolerance policy now at hospitals. As you can see, this picture here is a central line catheter with a chlorhexidine disc, and that's something that's newly implemented to prevent infections at the site of the skin where it enters. And that's where the majority of infections occur, is from bacteria entering at the skin. Our solution is to use blue light to kill the bacteria and prevent the bacteria from entering inside the body. As you can see here, bacteria, by these red guys here, start on the skin and then they work their way down the catheter into the blood. Once the bacteria is in your blood, you can form sepsis, which is very dangerous. We believe that by using our blue light treatment in addition to the current methods, we can reduce infections and save the hospitals and Medicare billions of dollars. So how does blue light work? Well, essentially, the blue light shines on the bacterial cells and activates photosensitizers, which then release reactive oxygen species that lead to DNA damage and eventually cell death. So after speaking with multiple nurses and hospitals and physicians, and analyzing the market, I see that there's a $1.7 billion available to be made in this market, and we believe that we can capture a potential revenue of $230 million. We'd use two revenue streams by having a razor blade model, a disposable patch device, as well as a reusable light source device. And we would be integrated into hospitals' procedures. So it'd be standard protocol for every central line catheter being used across the board. The hospitals are highly incentivized due to the HAC reduction program implemented by the federal government, where hospitals that don't meet certain protocols lose 1% of all their funding. And in 2015, that was $364 million lost to hospitals due to not proper treatment. And central line infections account for 25% of the metric used. So there's high concern from the hospitals and large interest in this. For example, with Baylor Scott & White in Temple, where we would like to be the first to implement, we can see a revenue of $140,000 with potential for all of Baylor Scott & White hospitals would be $1 million in revenue per year. So over the summer with ATI, I've analyzed the intellectual property protection and strategy and come to realize that there's a lot more device design complexities involved in our patenting process. As you can see here in this diagram, we'd like to start wide and work our way down narrow and then have more breadth in our IP. However, currently in the blue light space, we're looking at it being narrow, and we're in the process of finding a new design that will allow us to capture more of the breadth and improve our IP protection. So that means there's more R&D work needed for our device design. However, this is a promising technology with a large market impact, as well as large healthcare impact. So this is a slow go, is what I would call it. So for the regulatory process, our design history file is really what we need to be focusing on. And it's an iterative process where we need to look at the user needs at the hospital as well as the device needs inputs and keep reworking this design. We need to make a functional prototype and work with regulatory consultants to navigate a 510K process. As far as our next steps going forward, our roadmap would involve filing a new provisional patent, working to design our functional prototype by figuring out the user specifications as well as the physical specifications, and to receive an STTR grant to go through this iterative design process, eventually leading to filing a utility patent. At that point, we would have a better idea how much the FDA approval process would cost and if this would turn out to be a viable business solution. The team of Scepter Medical Devices, I've been the team lead. We also have Dr. Glow, who is the co-founder and the TIPS imaging director. We've got Jennifer Jordan, an engineer at Texas A&M. Dr. Robert Smith, who is also a co-founder. Dr. April Lovelady, who came from NASA to work with us. And our mentors, Terry Chase and Dr. Sagwa. And I'm with Scepter Medical Devices. If you have any questions, please see me after.